Okay, boys and girls, welcome back. This is lesson 5, session 1. So you need to get your books and open to page 87. This is lesson 5, session 1, page 87, explore expressions with exponents. So we're going to go ahead and look at the problem today. It's kind of a short problem. Let's go ahead and read the directions. Previously, you learned about using exponents to write powers of 10. I think you did that in 5th grade. In this lesson, you will learn about using exponents in both numerical and algebraic expressions. Remember, numerical is with the numbers like 2 plus 3, 5 plus 7. Algebraic throws in a variable, has a letter like 5 plus n or 2n plus y. Those would be algebraic expressions. So we're going to learn how to use exponents in both of these types of expressions. So use what you know to try to solve the problem below. David builds a house for his cat using cubes with edges that are 1 foot long. He builds the house by making 4 layers of cubes. Each layer is made up of 4 rows and 4 columns of cubes. How many cubes does David use for the house? Okay, seems like a lot of words there, so let's break it down and see what we know. David builds a house for his cat using cubes with edges that are 1 foot long. So we know we've got cubes. Let me draw on this. And we have cubes that are 1 foot long. So they gave us that. And if they're cubes, they're all the same length. And he builds a house by making 4 layers of cubes, and each layer is made up of 4 rows and 4 columns of cubes. How many cubes does David use for his house? See if you can pause this and come back and see if you get the same answer that I do. Okay, if you have paused this and come back, what I would have done, one way to start is I know I have, whoops, this is terrible drawing. I have 1 layer and it has 1, 2, 3, 4 by 1, 2, 3, 4. So that's a 4 by 4. And so that means this first layer, my bottom layer, is a 4 by 4. And I have 4 of those. So a 4 by 4, and I would have is 16, and 16 for the second layer, 16 for the third layer, and 16 for the fourth layer. So if I added those up, 16 plus 16 plus 16, I'm going to get 64. So I figure David uses 64 cubes to build his cat house. Another way we could have done it is if I know a cube, and let's see if I can draw this. And it's a cube, so I know all the lengths and sides and height are all the same. So I know it's a 4 by 4 by 4. So in this one, on the bottom, I would say there is a 4 by 4, which is equal to 16. And I have that 4 times. So 4 times 4 times 4. And that is equal to 64. So in the first example, I could have added. I added my 16 and 16 and 16 and 16. In my second example, with the cube, I multiplied a 4 by 4 by 4. So let's go ahead and move on to the next page. Look on page 88. And let's see if I can get rid of this. There. Okay, look back. How many cubes does David use for his house? How can you find the number of cubes? Well, we already said there were 64 cubes, and you could multiply to find the number of cubes in one layer. Multiply one layer by the 4 layers. So if I find out how much one layer is, I can multiply it by 4 to get the total number of cubes. So look ahead. One way to solve the try it problem is to use repeated addition. Another way to use is to use repeated multiplication. You can show repeated multiplication with an exponent. You have used exponents with the powers of 10. Write the power of 10 to the 5th as repeated multiplication. So if I had 10 to the 5th power, that means I have 10 5 times. 1, 2, 3, 4, 5. So I did my repeated multiplication. Make sure you've written this down. You can also write powers with numbers other than 10 as the base. What are the base and exponent in the power of 3 to the 8th? And write 3 to the 8th as repeated multiplication. So they give us an example over here. The base is the big number that it's sitting on. The exponent is the small number at the top, and that's telling me that I have 9 4 times. So my base is the number it's sitting on. So what is the base and exponent in 3 to the 8th? The 3 is my base, and my exponent is 8, is my exponent. And how would I write that? As repeated addition. Remember, I'm not going to do 3 times 8. I'm going to do 3 times itself 8 times. 3 times 3 times 3 is 3. 1, 2, 3, 4, 5, 6, 7, 8. And don't forget, we could have also used the just that dot to represent multiplication, so it wouldn't make it quite so long. What are the base and exponent in 3 to the 1? First power, write 3 to the first power without an exponent. So the 3, the base is my 3, and my exponent is 1. So that means I multiply 3 one time. So therefore, how would I write it without the exponent? Just as the number 3, because it's 3 by itself only one time. So we can use exponents with variables, and this time we're going to use the variable s to represent the edge length of a cube. Then the volume formula, v equal length times width times height, becomes v equal s times s times s, or v equal s cubed. A lot of words there. But you already know this. To find the area of the cube, the volume of the cube, you're going to do volume is equal to the length times the width times the height. Well, we are just going to substitute with a cube. We know these are all the same size. So the volume is equal to the side times the side times the side. So that means s times itself 3 times. So when you see s to the 3rd power, that's cubes. So if I knew the length was 4, so they gave us the length, I'm going to substitute. Volume is equal to 4 cubed. Now I want to think about that 4 cubed. Is that 4 times 3? That's going to be the biggest mistake people make. That is not 4 times 3. That is 4 times 4 times 4. I can do 4 times 4 is 16, times 4 is going to equal 64. So let's look at the next one. Reflect. How are the expressions 2 to the 7th power and 2 times 7 alike? How are they different? Well, one way they're alike is they use the same numbers. And one way they're different, well, another way they're the same is they have the same numbers. So they're alike with the same numbers, and they both use multiplication. But these are certainly not the same value. If I did 2 to the 7th, that would be 2 times 2 times 2 times 2 times 2. It's 2, 1, 2, 3, 4, 5, 6, 7. And this would be 2 times 7. 2 times 7 is 14. What is this one? This is 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Wow, that is certainly not the same answer. So be careful. The biggest mistake is people are going to think the exponent means you just multiply it that many times. You multiply it by itself. This shows you 128 is certainly a lot bigger than 14. You are going to do the next 2 pages by yourself. Make sure you complete these and bring them into class with you. And the first one is this next page. Prepare for writing and evaluating expressions with exponents. Think about what you know about the powers of 10. Fill in each box. Use words, numbers, and pictures. Show as many ideas as you can. This is just a brainstorming. So in your own words, what does the power of 10 mean? What do you know about it? Give me some examples and give me some non-examples. And then what power of 10 can you write to show the number of small cubes in the model? Explain. You might want to count one section of the cube to see what we've got. And you'll need to write that down. And then the next question. A restaurant keeps eggs in a rack that has 5 layers. Each layer has 5 rows with 5 eggs in each row. How many eggs does each 5-layer rack hold? Show your work. This is exactly like the problem that we did together. And then check your answer to problem 3A. Show your work. So you will need to complete those 2 pages by yourself. And hopefully you will bring those all in to me finished.